Hello everyone. So today we are solving a question of JEE ADV 2020 from the topic of direct electricity. So let's first read the question. So it says that they're given a semicircular metallic strip which has thickness of T and resistivity P. Its inner radius is given as R1, outer is given as R2. If the voltage V0 is applied between two ends, that like they are talking about these ends, and in addition to it, there observe the transverse voltage. Transverse voltage means they are talking about this delta V here, one from the outer edge and one from the inner edge, and due to the kinetic effects of moving electron obviously, and then figure is schematic and not potential. Okay, so we have to tell all the like which options are correct or not. So starting from current, so to find current, what we have to do, we have V naught here and we have to calculate the R equivalent. What is R equivalent will be here. So this is not very simple step that we usually see. What we can do is we will consider a component like thing. Let's suppose at some distance R from center, this is the center, at some distance there is some small component of wire like this. Okay, and if we integrate over this whole distance, so what we will get, all the resistance are in they are connected in parallel. So because you can see that they both are sharing, they all are sharing some same potential here, that is V naught. So we can consider them, they are in parallel. For parallel combination, what is the R equivalent? We can write R equivalent is equal to like sigma 1 by R this. Okay, let me write for one component. What is the resistance can be? Resistance is nothing but rho L by A. Rho is the same for all. What can be L? L is nothing but what we will measure from here. If suppose we are considering R distance, okay? So what will be its length? It will be nothing but 2 pi R. 2 pi R. What will be L? A, sorry. A is nothing but, if you have read this question properly, they're given a thickness is equal to T. So if we draw it like this, so the area is nothing but T dot dr, because we are considering a very small component of dr which has thickness T. So we can get area is nothing but T dot dr. Now this is R. So to make R equivalent here, what we can do is we can integrate it over the this complete radius from R1 to R2, from R1 to R2, T dot dr by rho into 2 pi R. Now, all considering all other things as constant, we can get 1 by R dot dr. It is nothing but 1 by R equivalent is equal to 1 by R is ln. So T by rho 2 pi ln of R2 by R1. So again, like reciprocal, do the reciprocal. So we can get R equivalent is nothing but rho 2 pi. We know that if we reciprocal it, okay, let me write first ln R2 by R1 into T. Okay, now what will be current? It is nothing but V by R. V is given as V naught, so we can divide this R equivalent here. So rho 2 pi T, again ln will go there, R2 by R1. So let's see whether it is matching our option. Absolutely yes, it is matching. V naught T. Sorry, I have no. Okay, wait. Pi and rho and T should be. Wait. Yeah, actually, like it should go from, should be there and it will go there, and yes, it is matching now. So for our option B and C, the both are same thing, but they are asking for okay, let me check. For option B, it is saying that the outer surface is at higher voltage than the inner surface, or the outer surface is at lower voltage than the inner surface. So on what thing this depends? We know that there will be some electric field here. Okay, why there will be electric field? Because if we say that suppose there are charges moving, current will flow only when the electrons will move. Okay, electron will move. So we can see that this is a circular path among which the electrons are moving. So electrons are moving with a some centripetal force. So what that centripetal force could be? It will be nothing less than like the electric field only. Electric field will provide that force. So centripetal force will act like this. But we know that electron moves in the opposite direction of the electric field. So electric here, I did one mistake here. We know that electron follows, like suppose, let me show with you an example. If this is an electric field, generally the force experienced by a charge in presence of an electric field is in the direction of electric field. But electrons are, what are electrons? Electrons are nothing but a negative charge. They have negative charge, so they follow opposite the path of electric field here. So to do the circular motion like this, the electric field need to be outward. Okay, and we know that when electric field is outward, like if you know this or not, E is nothing but minus del V by del R. That the change of voltage, the change in voltage decreases in the direction of electric field. So if we are saying that this is our bimetallic strip, no, sorry, not bi, it is just metallic strip. So if in this direction the electric field is there, so our voltage will keep decreasing from here to here. So delta V will be, I mean the V will be higher here and V will be lower here. So let's see which option is matching that. The outer surface is at higher voltage? No, the outer surface is at lower voltage. It means the option C is correct here. Okay. Now to check for option C, option D here, I mean I can do the incorrect, mark option B as incorrect because C is correct only. For option D, what we have to do? If you know that what is I here, I in any conductor, it is nothing but equal to NeAVD. Let me introduce you all the terms. N is nothing but number of electrons. E is charge of an electron. A is the surface area of conductor or the area of conductor. And Vd is nothing but, it is a drift velocity. Okay. So keeping all these things in mind, what we can do here, yeah, so we want to find delta V as L square. So as I told you, the equation above, that delta that E is equal to minus del V by del R. So we can write that E dot dr is equal to delta V. Okay. And I have also told you that the electrons are feeling a centripetal force, and we know that what is the speed of an electron here. So it will be nothing but drift velocity. So we know that when any particle experiences centripetal force, it is nothing but equal to mvd square by r. What is r here? We can take any radius like r anywhere. Okay. So this is the experience. This is the force experienced by the electrons here, and which is what is providing them its speed. It is nothing but E, or this is the electric field, and this is the charge on an electron. So if you consider this equation, we can see that E is proportional to Vd square. Also, we know that Vd is proportional to I here. Vd is proportional to I here. So even if we consider like E different also, we can see that the E is directly proportional to delta V here. It means delta V is proportional to Vd square, and Vd is proportional to I. That implies that delta V is proportional to I square. So it means our option D is also correct. Hence, what we got our answers correct as A, C, and D. Thank you, everyone.